Ever pondered the significance of calibration and measurements in the vast field of mechanical engineering? Well, these methods sit at the heart of precision, efficiency, and safety. Today, we delve into the world of mechanical measurements and calibration, guiding you through each method in a step-by-step manner. We'll kick things off with the calibration of a pressure gauge, a process that ensures the gauge accurately measures pressure. First, connect the pressure gauge to a pressure source. Then, apply known pressures to the gauge and record the readings. Compare these readings with the known pressures to identify any discrepancies. Finally, adjust the gauge accordingly to ensure its accuracy. Next, we have the calibration of a thermocouple, a device that measures temperature. First, immerse the thermocouple in a substance with a known temperature, such as boiling water or melting ice. Then, record the thermocouple's voltage output. Compare this output with the expected output for the known temperature. If there's a difference, make the necessary adjustments. Linear variable differential transformers, or LVDTs, require calibration to ensure they provide accurate readings of linear position. To calibrate an LVDT, first connect it to a power source and a readout device. Then, move the LVDT's core to known positions and record the readout device's readings. Compare these readings with the known positions and adjust the LVDT if necessary. Load cells, which measure force, also require calibration. To calibrate a load cell, first zero the readout device without any load on the cell. Then apply known loads to the cell and record the readings. Compare these readings with the known loads and adjust the load cell if necessary. Lastly, we can determine the modulus of elasticity of a mild steel specimen using strain gauges. First, attach the strain gauge to the steel specimen. Then apply a known force to the specimen and record the strain gauge's readings. From these readings and the known force, calculate the modulus of elasticity. In the realm of metrology, precise measurements are key. Tools like the Optical Projector and the Toolmaker Microscope precisely measure small parts. The Sine Center, sine bar, and bevel protractor accurately measure angles. The Autocollimator and roller set measure alignment. The lathe tool dynamometer and drill tool dynamometer measure cutting tool forces. The tally surf and mechanical comparator measure surface roughness. The gear tooth vernier and gear tooth micrometer measure gear tooth profiles. And finally, slip gauges calibrate micrometers and optical flats measure flatness. In sum, calibration and measurements are crucial in mechanical engineering. They ensure precision and accuracy, contributing to efficiency and safety. Whether it's calibrating a pressure gauge or a thermocouple, measuring angles with a sine bar, or assessing surface roughness with a tally surf, each method has its unique steps and importance. So remember, the next time you marvel at the precision of a machine, know that behind its efficiency lie these critical processes of calibration and measurement.